Yeah. So if we have an array and we're going to convert it into a vector, and we straight away create one array that is x, and we check the class of it, and we see the class of it is array. Fine. Now thing is, for any damn conversion, you want to convert array to vector, vector to array, or anything. Okay, maximum number of time you see it is convertible. Okay, and how it is convertible? You just type as dot what you want to do. You want to make it to vector, as dot vector. Okay, and give the name of the element you want to convert. So I want to convert x. Okay, so now what we'll do is we'll create another variable and keep this converted array into that vector, into that variable. So I created y. Now check y. So y is there. Fine. So this is convertible, but at times you will see some elements are not convertible. Okay, and if it is not convertible, it is not convertible. We cannot do anything. Fine. So this is how we convert, and just keep in mind as dot vector. If you do as and then dot as dot, and you see so many things are there, as dot vector. Okay, as dot data frame. Okay, as dot array. If you want to convert something to array, so you can do it. Okay, now if you want to convert integer to character, as dot character, as dot integer. Okay, so it is there. You can use this in multiple ways and multiple cases. Fine. Any other questions? Yeah, if you want to speak out, please, if you want to speak out, you can speak it. Jennifer, was I clear? Okay, great. So Anish, this question, what is side tabs? So from where you are getting this? Okay, fine, we'll see this, Jennifer. Okay, objects, as I said, here in my case, at that particular time, it not perform that way. Factor. Okay, basically the concept of factor is you create one object, you have a data set which we'll see, and that is normal categorical variable. That is not a factor. But if you convert that into a factor, the object size should reduce. Okay, this is normal expectation, and this is what happens. Okay, so at times very not that frequently, but you will see opposite happens. Okay, you see the things happening in opposite way, but not to worry about that. Is that generally happens due to a system issue. Okay, you clear out your cache and history, probably you'll be able to see the same thing. Okay, because that day when I was showing you the concept of factor, I again observed the same issue. Fine. So what we'll do is probably we'll start with the session. Okay, and okay, Amartya. So we'll take this as well. Okay, I have created a document. Okay, on installations. Okay, apart from CSV, there are other file formats which you need to have. Okay, so probably I'll share that document with you, with everybody, and you can go through that. This is a normal package installation. And package installation, I have forgot to show you the other way, which I'll start with that only. Okay, the thing which I have missed in the last session. So guys, so if you remember, if you remember, whatever package installation we have seen. Okay, we are yet to see the detailed package installation, but there are always two ways. Okay, you talk about import. We did import from CSV, right? So there's what is the other way? You create any uh, variable, okay, and you can write read dot CSV, and then you can give the path where your data lies. This is again a way you can read it. This is the other way. If import.csv is not there, you can write code and import the file. Okay, I'll show one case, one example to you. And to install the package, what we do is we generally go and click on install, search for the package, and then we install it. Okay, but once you go into production, or once you go into live work, you are not going to do it manually. So people generally write scripts. Okay, so what is the script? Install dot packages. Okay, package name, let's say I'm trying to install dplyr. Again, dplyr. Okay, and packages generally, to be on the safe side, this is just a precautionary measure we take. Package generally are dependent on multiple other packages at times. If there's a package called dplyr, that can have some dependencies on other packages like plier, uh, let's say SQL and all. So what we do is we write dependencies is equal to true. What it does is it will install this package dplyr, and at the same time, if it finds in the repository that this package is dependent on any other package, straight away install that package as well. Okay, so there's no headache on your side, like you need to scroll, search, find that what packages are dependent on here on this package, and then do it manually. Okay, but the same thing, this manual effort, you will have to do it when you are doing a UI installation, when you are doing it from UI. Okay, when you do UI installation like this way, then you will have to go individually and search the dependent packages and install it one by one. Okay, but this is a savior actually. Okay, just click on enter and it will start installing the packages with the dependent packages. Okay, so this was the other way which I was sure. Okay, so the idea is, yeah, that is the case. So label, the more number of label you have, so let the package get installed, and in meantime I'll answer one question. So there's one question. The question is, when we create a factor, okay, and in that particular factor, we see there's a label, there's one label. Okay, for example, I've I showed you here, right? So if I create one variable x, and that variable is nothing but repetition of I love R. Okay, and it is getting repeated 100 times. Okay, so if I see this, what is there? No, where is that code? Can anybody ping me that code, because I have closed that tab which I wrote that day? Example, the same example. Okay, so we'll take the same example now. What we took is that we took without factor. So we are replicating I live R 10,000 times, and once I execute it, so I see the object size. It shows 80096 bytes. Okay, and we see the structure of it. So we have this is not a factor because we don't see any labels, right, guys? Now we don't see any labels, so this is not a factor, and the size is 80096 bytes. But at the same time, what I do is I convert this into a factor. How do I do this? Fact. I didn't convert it. I created a new variable called fact, and this is a factor. Instead of a vector, it's a factor. Okay, converted factor. Now the same content. If I do this, I create this and see the structure. So yeah, it is a factor with a label, and there's only one label. So in this entire thing, I love R is one label because this is the thing which is getting repeated, and the thing which is getting repeated, that will only be the label. Okay, so let's say Sajid R. Okay, programming. Okay, so if this is the string or a character that is getting repeated again and again, just understand this. Sorry. Now if this is the three strings, a character which is getting repeated again and again, so when I convert this into a factor, okay, let's say this is getting repeated 100 times or 1000 times. When we convert this into a factor, so we'll have three labels. Why? Because we have three different strings, right? See, we have three different strings separated by comma, but at the same time, and the size of this will be more. Definitely this will be more. Now take this example again. Now what I do is I replicated I love R, and this is a single string. That is why if I check the size of this string, this particular string I love R with a single character is 40464. Okay, which is exactly half or somewhere half of what the actual size what we saw without a factor, and this is a single character. Now take another example. We replicate a multiple character vector. Let's say this. I'm dividing this only into a multiple character. Fine, guys, agree? Now I have three different characters, so probably it's a logical thing that I'll be getting three different labels. Now we got one label W backslash one labels. See here, this part, just to understand. Now when I convert this and see the structure, so we have three labels. Okay, and since the size of the labels, since the number of labels has increased, so we should expect this increase in the size of the variable. Okay, and see it has become three times. Earlier it was 4000. Now it became, when we had one label it was 4000. We created three labels. Now it is 12,000. Logical. Okay, now if you try and compare this with our original variable with one character, so obviously this will be more. So if you want to do a fair comparison, so convert this into a different variable, three different variable, and then check it. So probably that time it should be, generally we see that time it should be more. See here, it is 24 bytes, 24,000 bytes. Guys, are you with me on this? So what is the controlling parameter here? How many labels is being created? So here it is three labels, so size is more. Here it was one label, its the size was less. Okay, now coming to our real life implementation that we implement on real life. Okay, so when we get the data, and we even saw some data set last time, if I'm not wrong. Okay, when we get a live data, so we do not take this tension of converting something into a vector. Okay, that's not happen in maximum number of time. I'm telling you. Let's say this example. We take this example. We have a data set, some demographic data of a student. Okay, now here history. What was his score? High, medium, not available, low. Okay, so if I take a distinct of it, how many distinct labels are there? So this is again one of the major parameter. You see how many distinct variables are there. Okay, based on that you decide it should be a factor or not. If you have millions and like let's say 10,000 of distinct parameter, so distinct parameter 10,000 means 10,000 labels, and that will not at all save your memory. Okay, so factors are like basically it comes into picture, or when R automatically converts a variable into a factor when it sees there's a variable, there's a column which has a limited number of distinct variables and it is getting repeated. Like in this case, okay, we have medium, high, low, okay, and NA. So if we have a data set of 1,000 rows, okay, and 1,000 rows, you have in a column called history, you have four distinct variable. So this is less, and automatically just try it, import this into R, and you see this variable will be converted into a factor automatically. Okay, so let me do that. I have closed that. So now what I'll do is mm, so what I'll do is I'll try and sorry, where we, yeah, we were here. So first of all, are you clear with vector, the doubts you had? I'll create sample data read.csv. Okay, first let me check what I have in my directory. Yeah, so I already have direct marketing. That is what I opened. So I'll copy this and use it directly here. Okay, so I'm done. I've imported the dataset read.csv and the CSV name. Now let me check what you have in the dataset. So I'll view it. As I said, view sample data. So this is what I have in my dataset. I am seeing some pings. Let me see what you have. Thanks. Yeah, so I see the data got imported, and before we proceed on, I'll just like to make it clear, how to make your import using code easy. Okay, so guys, what I'll tell you in the initial days, okay, when you're just starting and you're learning things, so it will be very good. Create one directory for you, okay, or do one thing. Don't if you don't want to create one new directory, you know where R is accessing your default files from, right? It is from documents, okay, and just have a look. It will be probably uh, get wd, right? Type get wd, so it will give you your working directory. Okay, so probably it will be this somewhere in documents. Okay, now in documents, what you do is you create one folder, learn R learning or R tutorial, and copy that path. How will you copy that path? Let's say you created this folder, okay, R learning called R tutorial. Copy the path of it, get info. This is my path of that file. Copy this, go to R, okay, and just type set working directory, set wd, okay, and paste that path which you have copied. Okay, so what exactly you are doing? There's some default location where your R is addressing, your R is pointing. Okay, so in that case, everything is fine, you can work, but I'm trying to make your job easier. Okay, create one working directory for yourself. Okay, in this way you learn, as well as it will be easier for accessing files and all. Copy that path, set the directory path there, here, like this way, set working directory and path, and change it, and just execute it. So what will happen now, once you execute it, once you execute it, so keep all the files which I send you there, all the data file, all the sample file which I'll be sending you. Like let's say I'll send you this file. So copy this file, download this file, and keep it in that folder. In what will happen in that case, you will not have to write path here. So see here, I'm not writing any path C colon documents. I'm not writing anything because I've just, my R is pointing to the directory. If I just name the file, it will be able to access that is the reason why I checked directory, and I saw my R is pointing to that directory, and I straight away copied this file name and I bought it here, and it imported the dataset. Or else in traditional way, what we'll have to do is, I'll go back. Let's say I'll come here, documents. I'll come here. I'll go to, sorry, let's say I want to import this data like this way. So I'll have to copy this data path. Okay, I'll have to copy it, which you can do if you want to do it. Definitely, you are open to do. So I'll have to write like this way. Let's say sample data 2 read.csv, and then I'll give a path, this big path. You can even do this, and this will also work. Okay, there's some code. As I said, we'll have to give a double quote first, is the first thing. If not, then you'll have to change the. So in order to avoid all these things, straight away point to directory with some folder, keep all the files there, and straight away access it via name. That is the easiest way that I prefer.
So I have a question regarding the fact of that.
Yeah, tell me. So yeah, we'll take that question. Give me 1 minute. Okay, 1 minute. So see here. So I accessed it how? Instead of writing just a file name like this, okay, I give the entire path where the file is, followed by the file name. So in this way also you can access the file. So see here, in both the cases I have the file, I have the data, I have the data in this case as well, I have the data in this case as well. So it's your call which one you want to take it. Okay, either you give the entire location followed by the file name, or set this directory to this path. Okay, set the working directory to this part like this way, set working directory, set wd, give the path here like this, and then straight away start accessing the file with the names. Okay, these two are the difference. Yeah, so sorry, I interpreted in between. Can you please go ahead with the question?
How
You're
did
not,
you get that 24,000 by
you're not audible.
X thing? I didn't get that.
Yeah, I'll get. So that factor issue, right? Fine. I'm not clear with the question because your voice was not audible.
So in the factor part, how did you get that?
Yeah. So I imported that marketing.csv, and I imported in two different ways. Okay. The first way was like giving the entire path of the file and putting it in read.csv is the one way. The second way, to avoid frequent writing such a big path, I just wrote, I just wrote, uh, I just directed my entire my R to a specified directory, and then I am using only file name to access the file. Fine. Now, once I imported it, so I view it, and I just see, yeah, the data got imported. The data got imported. This is my data. So I see history is there. So now I'll have a look on different variables and understand. So what I'll do straight away structure sample data and see what are the different types of variable I have. Okay. So I have age, which is factor automatically, because, and why it is a factor, because once we go back to our data set and we see age is not a numeric, like 26 year, 22 year, 22.5 years, 27.2 years. So in that case, it will be a continuous variable. Okay. Here it is categories: old, middle age, young. That is it. We have three categories that I can see now: old, middle, young. Fine. So it has only three labels. So instead of having a normal variable, so R automatically converted into a factor, and it resembles here. See here. Yeah, age is a factor. Okay. Likewise, gender is a factor. Own home, married, location, these are factor. So you can justify it. Like you go to data set and have a look why it got converted to a factor, instead of have, if no, if it is not a factor, it will be a huge size, because the size of the data set will be approximately, let me check what is the size. So if I see n row means like counting the number of rows of the data set. So n row means I have 1000 rows. Okay. Now if I want to see the column and call, number of columns, number of rows. This is the command we see, and this is very frequently used. We have 10 columns and 1000 rows. Fine. We go back to our data set and we see, yeah, this all are categorical variable. This all are categorical variable. So it got converted into a factor. But we see one variable called salary, which is probably a continuous variable. It is a digits, continuous digit. Okay. So probably this is not converted to a factor. Salary, this is normal integer. Okay. Now children, again, one children, two children, three children, one children, two children, three children. So you see, it is, since if you see the distinct value in this, so it will be limited. It will be, it will not be, people cannot have from 1 to 100 children. No, it's not impractical. So they'll probably have 1 to 4, 1 to 5 maximum. Okay. So R have not converted this into a factor, and you see it is an integer, but you can do a little bit of investigation and convert this into a factor. Now what investigation I'll do? The very basic investigation that you can do here is go to that variable, okay, and check the unique values. I'll check the unique values, unique sample data. I'll particularly look at that uh, sample data dollar children. Where is children? Yeah, and I see how many unique values it has. It has only 4 unique values: 0, 1, 2, 0, 1, 2, and 3. Fine. So a person can have 0 child minimum or a maximum of 3 child. Okay, so you have 4 different variables. So you can straight away go, it's your call. Okay, if you see this is, you have a record of 10 million rows. Okay, it's a bank data. Okay, and you have all banking customers data, and you want to predict some credit card fraud or loan fault, and you see one variable is there called children of a customer, of a bank account holder, and you see there's a value 0, 1, 2, 3. you come to this conclusion 0, 1, 2, 3. So you can straight away go, and since the size of the data will be huge and converting that into a factor will reduce the size of the data, so you can straight away go and convert this into a factor. Okay, no one is stopping you, and that is what we generally do in data preparation part. So in a data science, or when you work in data side, okay, so you have three perspective, you have three cycle. There is a life cycle of a data set. So what is that? First is your data pulling and data understanding. Okay, you pull the data, required data, and you try and understand the data. So this trying and understanding each and every variable. Okay, trying and understanding each and every value it has. Is it continuous, categorical, factored, unfactored? Okay, so this is data understanding part and data pulling part. Then comes your analysis, all exploratory data analysis. You do analysis on the data set. Okay, post analysis, then you'd conclude and give some results. Okay, so these are the three cycles. Okay, major cycles. Fine. So you got an example. This is what I wanted to show you. So you pull out data set. Okay, and automatically see R converts. When I imported a data set straight away and I saw the structure of it, so R converted it into, according to itself, it converted which is best for him. Okay, best for R. And you see they have, it is rightly converted actually. Age was factored variable, it converted into factor with 3 labels. Okay, gender with 2 labels, and likewise. Okay, but it missed one, and that is children, which I feel. Then I can straight away go and convert it. And then history is factored with 3 variables, 3 labels, and likewise. So catalog, probably if you see and catalog how many unique values it has. So now we'll have to study catalog as well to understand, can I convert this into a factor or not. So again, the same way, unique value, name of the data frame, sample data is your name of the data frame, dollar, catalog. So it has 4 unique values. Again, you can convert this into a factor if you want. Okay, since there's enough number of factors you have, so yeah, keeping 1 or 2 non-factor variable is decent, no issues. Okay, so but making all to an integer and working, it will be a little difficult because the data size will be huge. Fine, guys, any questions so far, or should we move on? Fine. So now let's start with a few small functions or operations that we do in uh, our data frame. Okay, and that would be, I'll just take the same example of that data set which I imported now. Okay, that marketing. Now what we can do. So since we have this data set, what operations we can do here? Let's start with the statistical operations, the statistical function that we have very frequently here. Okay, now if I want to find what is the mean of the salary. Okay, so mean of, let's say I want to, if someone gives you, I want to know what is the mean. Okay, so what's our perception? Mean is can only be calculated on your numerical data. Okay, right? So mean of age, mean of gender, mean of age at least is not possible, because generally people find average age, because here we don't have digits. It is a middle old or something, so it's not possible. Okay, now if I want to find the mean of salary, so what R gives you is, you straight away write mean. Okay, if you want to know about mean, if you are not aware of, so definitely you can question it here, question mark mean. You'll get that complete description with the formula. Okay, so the formula is very simple. You just type mean. Okay, and the variable for which you are looking for a mean. So let's say for a sample data, I want to go for a mean of salary. So this is a mean salary, $56,000. Okay, this is one thing. So I guess I have told you how data frame works here. This is a data frame name. Okay, this is the beauty of data frame. You give a data frame name. Okay, dollar sign. So once you give dollar sign, automatically it populates all the column it controls. It has. So these are the columns that this data frame has. Okay, so you can straight away select and put it like this way. I'll mail you this data set. Okay, if you guys are yeah, so this link will help you. It has few data sets, some good data sets. Okay, or else I can give you another link. This is again very good. This two data sets set I very frequently recommend to all the learners. Okay, because it has I'll be using almost all the data set here from here to show you some hands-on sessions. Okay, when I move to linear regression, okay, and all machine learning algorithms. So again, we'll be using this data set. So for now, what I'm showing you is, if you see here, you have direct marketing.csv. So I'm showing you this data set. Go to the second link, download this data and upload it in R. Okay, whoever wants, they want to write code, they can write read.csv and import it, or someone who is people who are having import from CSV option, they can use that option. Okay, that's your call. Fine. So let's move ahead. Now I want to know. Let's say I want to use second. Like I'll do it. Okay, Nipan. So now I want to. Okay, I'll send it later on. I have pinged you as well, I guess. I'll send them in a mail as well. I'll keep this both the links for the candidates who are not there in the session. They can actually access the data set. Fine. Now, going ahead quickly, we saw mean. Now max. If I want to see what is the maximum salary, so again the same way, just write max and the column on which you want to see the max. The same concept applies there. So 1,168,000 is your maximum salary, and similarly you can see minimum salary, and there's an n number of function that you can see here. I can use this way as sample data dollar salary. So you get minimum salary here. Fine. So $10,000 is a minimum salary. Fine. Now this something which you can look at. There are many functions. Okay, which then there is unique. Unique already we have seen, but unique is very helpful when you want to convert something into a factor or not. So if I want to see unique value of, of child we have already seen. Let's say I want to see unique value of a own home. What is the unique value in own home column? So I see either it's a factor. Okay, now if you don't see the structure and then you see the output, and you'll get to know if the output comes with labels. See here, earlier whatever we saw, there was no labels here. Okay, integer or some anything. But once you see factor output, you'll get to see the labels. So output is own or rent is the output, but it comes with labels. That there are two labels. Own and labels are the own and rent is the labels. So this signifies that this is a factor. Okay, so likewise you see unique value of each column and you will understand. Fine. Now, so this was something in data frame operation. Now I want to know what are the column names you have. Okay, so this is the operation call names. This is a function, and you give the data frame name. Sample data is the data frame name. So you get all the column names. See here, you get all the column names, right? So I'll just paste all the functions that we are using at one place so that it will be easy for you to revise it whenever you are doing. I'll send this code as well. Let's move ahead. Yeah. Now coming to the important part. Let's see this air passenger. What we have in air passenger. I have only one row, so I'll not consider this example. Yeah. Let's start here only. Okay. Now the important part is this is a data frame, and there can be a situation where I want to access not the entire row. I want to take particular row or a particular column. Okay, I want to access, let's say, only columns from salary till amount spent, or let's say I want to access only child and gender of the entire data set. Okay, and I just want to access the first 10 elements of a data set or the last 10 elements of a data set. So there are various permutation and combination that can happen based on the requirement. Okay, so now what are the operations? So these operations where you try and pull some part of the data set of a data frame. Okay, this is called subsetting of a data frame. You are subsetting the data frame. If you can recall it from your mathematical concept, so you have an entire set and you pull two elements, okay, from that set. This is called subset of that superset. Okay, from that it is derived, I guess. Okay, that if I want to pull out some part of the data frame or from some part of the data from the data frame, entire data frame, so that is called subsetting of the data frame. So you have whole new topic in R where you'll get to see there are packages subsetting data in data frame. This is one topic where you will get to see like very good concept. There are various packages, and basically data manipulation that we have sent you last time slides that basically covers that subsetting, and the packages dplyr that we'll see, dplyr and plier, so they all deals with subsetting of data frame. So you can understand how important it is. Plier. Okay, once you have a package entirely, when you have a dedicated package to do this job, okay, so you can understand how important it is, right? So when we start seeing it, so I want you guys to be in a situation like where you understand what a data frame is and how to query. So you should be comfortable in writing like basic queries till that time. Okay, for now I'll show you some sample, some subsetting so that you can get the feel of it. So let's say sample data is what you have imported. Okay, now this is a data frame. So there's a very important role, you can say, of a brackets. Okay, so what is the importance of a bracket? So till now whatever we have seen, we saw with a first bracket. Okay, this curly braces, no, this is not curly braces, this is a first bracket. Okay, this is one type of bracket use in R. There is a second bracket which is called curly braces, which we use very frequently in R. Okay, and there's a third and the most important braces that we use in R is a third braces. So these three brackets, you will see these three are the only brackets that we have in R, that we use in R very frequently, and they are specified to some, the majority of it, not always, majority of it is specified to jobs, specified jobs. So let's say first bracket. So you'll see whenever you operate with, whenever you deal with vectors, okay, arrays, you'll see this. Okay, whenever you operate, this will be coming in when you do write some algorithms. Okay, algorithms or functions, you create a functions. Okay, so we use third bracket. Okay, I'm just talking the majority chunk of it. Now this third bracket or square bracket we call it. Okay, this is majority of it, you can say 70% time it is used in data frame. So this is a dedicated thing for data frame. when you do data frame subsetting of data frame, when you are trying to work with a data frame, okay, uh, you trying to put some, you impute some statistical thing in your data frame, so we use square bracket. So just keep in mind, again this is the second time I'm telling you to keep something in your some part of mind which you can always recall it, kind of RAM, okay, always reading it. So this thing you should keep in your that part of mind. Like first is your vector operated, vector or array operated bracket. Second is your curly braces, and third is your third is your third bracket or a square bracket. Fine. Am I clear, guys? Fine. Perfect. So let's move ahead quickly. Now uh, we'll look into this data frame. We imported a sample data. Okay. Now if I give third braces, okay, third braces means I'm trying to subset or access the data frame. Now there's a comma. You always see this when I'm just talking about the frame framework. How do we deal with it? So left side of the comma is your row always. Okay, right side of the comma is your column. Now you should be clear that anything if I'm doing on the left side of the comma, I'm trying to manipulate or I'm trying to do something, okay, with the rows. Okay, the moment I go on the right hand side RHS, so I'm trying to do this some kind of thing with the column. This should be remembered. Let's say for example, if I create the same thing, do the same thing in a big data frame, you'll not be able to understand. If I do the same thing here, you'll not be able to understand. So let me create this data frame, which is this. Okay, quickly. Rows, data birth bind. Now let me check. So this is my data frame. My data frame is data frame true. Fine. Let's move ahead now. Yeah, here. Now where I wrote that concept. Here. Fine. Now, yeah. So what was the name of the data set? My DF is my data frame. My DF is my data frame. I'll just have a look. Correct. Perfect. Now let me write this thing which I wrote it for you. Yeah. This row and column. Now this is a small data frame. The reason why I have taken this small data frame, because you will be able to see the result. Here you'll get somewhere lost and not able to find like why, which row, which column I'm referring. Okay. That is the only reason. So let's take the small data frame, and what I'll do is I'll try to uh, take subset few columns. What I'll do is I'll take column my df data frame and take row. I'm trying if I, yeah, at the same time, if you see I left something blank. If I left some left side blank or right side blank, the moment I leave it blank, that means I'm trying to access the entire thing. All, it signifies all. So let's say I want to access first and second row, and I leave the right RHS, that's the column side blank. What does it mean? That I'm trying to access first and second row, from first to second row, and all the columns. Just run this. See here, I'm trying to access first and second row and all the column. Guys, is it clear? See here, the highlighted part, I'm trying to access first and second row with all the columns. Because why? Just try and relate it with the code. So here in the code, I have written first till second column. So colon means continuation from first to second, and it means both inclusive. Starting with first, starting with one, it will go to two, and both inclusive. Okay, you will find some concepts which will come in later on, where you'll see there's a concept of starting from first till second, not including second. Second is not inclusive, but in data frame it is inclusive. Both are inclusive. Keep this thing in mind. And comma, then column. In column I have not given anything, it is blank, so it took all the columns. But if I give, let's say, from 2 to 3, it means from second to third column. So if I run this, so see, it is again, the column is also getting subsetted. Just try and relate this. Now if I give 2 to 3, that means first is this, second is this. So second till third is it. So these two columns are getting selected from the column query, and first two rows are getting selected from the rows query. Now tell me, am I clear or not? Because this is a base, and if you like are not clear, I can repeat it, but be very sure about the concept.
Sir, can you repeat?
Yeah, definitely, I'll repeat. Any other queries you want to have here?
So I just want to understand the command section, how to write it.
Okay, fine. So the idea is, you need to look this.
Yes, sir.
Okay, and 1 minute. Now in this data frame, subsetting we do very frequently, and the other operation that we do very frequently, okay, the moment we import data set and we start doing that, is looking at the data set. Okay, and if you want to look at the first 10 rows of a data set, first 20, so I have already discussed this command called head. So head comes as a skip, it is very helpful to understand your data set. At least like, let's say head my df, run it, so it will give you the first 5. If you don't want to see, since it is very small data set, so let's say I want to see a the data set which I have imported, sample data. So I want to see the head of sample data. So see, you get the first 6 entries of your data set. Okay, and you can understand, yeah, what are the variables and what are the continuous, what are categorical variable. You can look very clearly, it is visible here. Okay, now if you want to see the like bottom 6 column or bottom 10 columns, so again you can do it, tail, okay, and the data set name. So it will give you the bottom values. You'll be able to understand, yeah, from bottom the value looks like this, from the top value looks like this. So it is, I see it is sync. There's no like majority difference. So, and you can even increase the number of rows you can, that will be visible in the on the screen. Let's say by default 6 is the number of rows that comes in. You can change it, give a comma and put the value. Let's say I want to see 10, so 10 number of rows will be visible. Okay, so these are the different operations that we very frequently do in R and in data frame when we import it. Okay, so let's move ahead. Yeah, so whatever we see in the screen now, that is from dplyr package. Okay, that is advanced filtering, and we'll see once we start a dplyr, we have a total different session. Okay, for dplyr long sessions. So we'll see how do we filter writing queries, how do we write queries. Okay, so we'll see all that. Fine. So guys, so any questions? So probably we left at uh, data frame operations. So we'll just complete that quickly, and we'll go ahead with other topics. Okay. So the exercise file which I'll send you, I'll take you through the exercise file so that you understand well. Okay. So we saw head and tail. Okay, so now there will be a situation. Let's create the situation. Okay, where you'll have to change some value. Okay, that the value is something, and you are not, that is not appropriate, you can say. Okay, so you can even change the value. So how do we change the value? Let's say uh, we know our sample data. This is how it looks. Sample data. Sorry, it's big. Let's take the small data frame, the one which you are looking at. Yeah. So this is my value, but this particular value, okay, which is in third row and fifth column. 1, 2, 3, 4, fifth column. Okay, third row, fifth column. So it's kind of matrix. Okay, if you want to take it in that way, it's a matrix, third row and fourth column. Third row, comma, fourth column. And this is the value which you want to change. Okay, and you want to make it, instead of male, you want to make it female. Or let's say we want to make it null, for let's suppose. So you can do it this way. Just refer to that cell, third column, third row, fourth column, and the value which you want to change to. It will not accept any. Okay, so let's say it will accept only null. No, so it is not accepting value NA. So let's me give it some 2, 3 if it's accepting. No, it is not accept. Generally, okay, since it is defined, that's why it's not accepting. But yeah, so if I this data frame, since I have created, you can do it in sample data. Okay, but I don't want to disturb that. But if you want to change any values, okay, so this is how we change it. You refer to that cell and the value you want to define. And the second thing is, if you want to add any column, so that is again possible. So let's say data frame. My data frame is your data set, and you want to add one more column here. Okay, so how will you add? Let's say you want to add location. Location is your column, new column which you want to add. And for now, let's suppose you assign value null. Okay, so what happens? This entire data frame got modified, and now if you see my data frame, so you see one more column that got added. Oh, this value got changed actually. See here, this value actually got changed that time. London, India. Okay, US. How many values it has? 1, 2, 3, 4 columns. So one more country. Okay, I'll assign these values to it. And so if I check it, so one more column got created with the values which I give. Okay, so this is how you do it. Adding in, like adding more column this way, and if you want to make some values, so straight away go to that cell what you want to change, and that null or something you want to put. So like we did here. Now second thing is, you can access it like if I want to view dataset, I don't want to there are two things. Okay, here in data frame, always there is some operation called in place operation. Okay, and something called temporary operation. It's like I'm just giving you a term to understand. It's not like bookish term. it will be fine. You will be able to find book in a book or a PDF. No. So in place operation, what it does is basically it just according to your logic, it will give you the output, but it will not change the actual data frame. Okay, the actual data frame will be as it is, but you'll get the modified output. But the moment you get the output, the actual data frame regains its shape and size, and it stays there. Okay, this is one thing. And the this is a temporary operation. Now in place operation, what happens, whatever operation you do, that actually modifies the data set, the data frame. And that was the reason I was not trying to hit this sample data and I'm trying to make null. That in there, if I want to make anything null, that will happen. Okay, but it will happen permanently. Okay, then again, if I want to gain like if I want to keep the original data set, I want to work with the original data set, I'll have to import it again, and everything needs to be done again. Okay, so keep this thing in mind. There are in place operation and there are temporary operation. So the thing which I have show you now, the thing which I have, like this thing, I've taken a data frame and added a column. Okay, and I've given the column names, and when I view it, so I see it is there. Okay, and it's no matter like I view it one time or 100 times, it will always be there. Okay, what does it mean? It means that your actual data set is being modified. Okay, the actual data set is modified. So this is your data set. Okay, and this is modified. Now if in case you don't want to use this, so you definitely you can delete it. Like how will you delete it? I'll just show you. Let's say you are creating my data frame 1. Okay, and what you want is, you don't want the added added column, and which is which is, let's just count it, 1 2 3 4 5 6 7. You would want 7th column, so -7. Okay, so if you do this, so uh, the data set is again back to its form. You don't have the 7th column which you added. Okay, but the data frame which I modified will still have this column. See here. So this is the difference. So this is basically whatever operation I'm doing, it's happening. A modification is happening to an actual data set. Okay. Now, if I go to our data set and I do some operations like I want to find mean, okay, or let's say if I want to find the maximum, so that is not happening with the actual. It is just using the actual data set. It is performing the operation and giving the output. At the back end, data remains in place. Okay, there's no changes in that. So a good example of that will be, let's say I want to fetch out the name of a let's say I want to fetch out the second name of the people. Okay, so how will I do this? I have this option of either going to that column, and yeah, I'll just repeat it 1 minute. So I'm just discussing the temporary operation now. Then I can just quickly repeat both the operation so that you will be having a clear idea. Okay, so I'm talking about temporary operation. In temporary operation, let's say I check this data frame. This is my data frame. It has this many columns and rows. Now, if any operation that I do, let's say I want to pull out the second name. So how will I pull out? There are various ways of pulling out second name. Let's say I want to use indices 1, 2, 3. So I want to pull out all the rows. I leave it blank, and third column. So this will give me the second column, the third column of my data frame. So I got my second name. This is my second name. See, I just match it: John, Edgar, Walt, and Jane. I got it. But there's no changes. The actual data frame remain as it is. Okay, this is one thing. Now, what is the second way of pulling out? So my data frame, you just write my df and dollar second name. You pull it like this also. This will also work. But the moment you will use assignment operator with the data frame, like this, my data frame, and you do something like you want to modify. Here modification is not possible since we have created it. So this will actually modify the data set. So this is called in place operation. Okay, now I guess I'm clear with this. So we'll see various examples here every now and then, but just to reiterate. Okay, so in data when we work with data frame, so we'll have to keep on modifying and pull out data, insert data. We do a lot. Okay, so on a nutshell, you have mm, two types of operations. One is in place operation. In place is basically you actually modify the data set. Okay, and one is temporary. Temporary means that you are just using the data set to get your result, but at the back the data frame remains as it is. Okay, so one example which I gave you was uh, like in place operation. Yeah, we'll I'll show you. We need to add value, so you cannot add value. Okay, so you cannot add rows. So what rows you will add? So that is a basically you'll have to add in the data and we'll have to import it. Okay, so guys, that is the thing that is basically a variable I've created. Just forget about it. Okay, yeah. So in place operation I was discussing. So it will actually modify your data set. Okay, and adding row, we don't add rows here. Okay, we just we can like for our need we add columns. So this was the basic operations, and whatever I have showed you till now, that was without any packages. Okay, and the idea was that to make you understand how R works. Okay, what is the flexibility? It almost supports all the type of flexibility. Okay, if you want to like do some subsetting, but some for advanced subsetting, like where you want to write queries like SQL or like where you want to do advanced filtering, so we have packages like dplan. Okay, which we'll see. Fine. So that is yeah, temporary table is let's say a good example of temporary table will be I want to find mean of salary of all the data set in my sample data set. Okay, let's say salary. Okay, so am I affecting the actual data set? No, the actual data set is as it is. I'm just using it to get the value. Okay, but at the same time, if I create a new data frame called sample df2. Okay, and in that I actually want no, I am modifying, I'm deleting the second column. So you will second column. Okay, so what will happen if I see the data set now? So what I have age and gender. So if I do this operation, so I get a new data set which will not have a gender. Okay, now check this. So gender is removed now. Okay, and now you cannot take bring it back. It is done. Okay, all done. So this is called in place permanent operation. Fine. Any doubts? Great. Now what we'll do is we'll quickly see something which is very important. Rather, I'll tell you like just a highlight of it. Okay, and we'll see functions. Okay, and the reason why I'm showing you function today is because you can relate it from this, the one which I discussed today. So we have seen this in data frame. In DF we have seen this. Okay, we have not seen this yet. We'll see now. Okay, and we have seen this in array and function. So at least you'll be able to, whenever I now onwards when I started sending you mm, uh, like assignments, so you will be able to relate. Yeah, I'm seeing this bracket and this will be vector. Okay. Fine.
So in the 10 function, if we want to delete one particular row, for instance, then how do we do that?
Yeah, so if you want to delete row, let's say sample data is your original data set. Okay, and you want to you just want to have, let's say, sample data df3, name it data frame 3. Okay, now here you just want to have top 10 data set, top 10 or something. So what you will do is you pull out 1 till 100. We know it has 1 till 100, sorry, we know it has 1000 rows, right? We are just pulling out 1 till 100 and all the columns, so I leave it blank and run this. Okay, so this is a new data frame without affecting the earlier data frame. I didn't affect the earlier data frame, but I created a new data frame, and that is having only 100 rows. So this is a subsetting of rows. Now let's say n row. Okay, and sample data frame 3. So how many rows you have? 100. So this is one way of modifying. Now the question, uh, I don't know the name. She asked me that how to add rows. Okay, so adding rows basically happens not directly. You can add it indirectly. How do we add it? Let's say I created data frame 3, which has 100 columns. Now there's again another data frame which is data. Let's say data frame 4, and it has another 100 column, but it is from 100 till 200. Okay, let's create this. So we have two data frame, guys. One is data frame 3 and one is data frame 4.
Sir, what is this n row?
Yeah, 1 minute. So n row and n column, I discussed it today. N row and n column, just have a look. Okay, if you have any problem with the functions, at least, okay, just question mark n row, you will get all the answers. N row and all column return the number of rows and number of columns present in X. X is nothing but your object. Fine. Now, I don't know who have written this, so let me. There's someone else's screen which is visible here. Okay, so this is not my fault. I'm not a culprit here. Okay, this is Va. So yeah, n row is n column. You take the count of the row and column here. Now, the question was how to, since we are adding columns, we have seen examples of adding columns. How will add row? So add row will happen in that way, and that will r bind. R bind. So I'm binding rows. So what I'll do is I'll take both the variables which I've created, data frame 3 and data frame 4. I'll bind it, okay, and put it in a new data frame called data frame 5. So what happens? I've added row. So this data frame 5, what will be the count of the rows? Can you answer, anybody?
From 1 to 200.
I just binded data frame 3, which I created. Data frame 3 was this, from 1 to 200, and data frame 4 is from 200 to, this was the situation. This is 100. Just have a look. This was the situation. This is data frame 3, and this is data frame 4.
So it will be from 1 to 200 now.
Yeah, 1 to
1 to
200.
200.
Correct. So the total count will be 200, right? Sorry, name of the data frame. Give the name of the data frame. What is this? Oh, I have taken n call. So we'll have to take n row. Just run this. You get 200 1 to some reason, because 100 is getting repeated 2 times. Okay. This 100 is getting repeated 2 times here and here. That's why. You got it? So you can even add columns, add rows. Column definitely you can add. You can add rows as well. Fine, guys.
Thank you, sir.
Now, let's start with where we started. Yeah, here. So let's just delete all these things. Usually, let it be. I'll send it to you. Yeah. So we'll start with the third thing. That is function. This is our agenda for today, and I'll send you an assignment that has lots of questions on, like codes basically, that have lots of questions on functions. So start practicing with that. Okay. So now functions, what it is. So first, mean we have seen max, we have seen minimum, and many other. We saw and rows as well. And row, we saw and call. Okay. So we had this first bracket everywhere. Okay. And what were this? These were functions. Okay. These were functions. Now, why it is called function? Because function is something which has a name. Okay. And it has some functionality. So it has a name. Mean is the name of that function. Okay. And what is the functionality? Functionality is whatever data we give here. Okay. It will calculate the mean of it and it will return you a value. This is it. Now, what is going inside, you are not aware of it. How mean is getting calculated, how will you get to know it? Okay. Since it is the code, you have not seen the code, you know the logic, but you don't know the code because code is not resembled. Okay. It's not visible here. Not even here. Code is not visible. Okay. But you know the concept of mean. So R has various functions which just name it and use it. Okay. This is called system defined functions. This is called this is called system defined functions. Fine. Now, what it has just the name and it returns you the output. So you the output. That is it. It does name and output. Okay. Examples are this: mean, max, minimum, rows, and call. Okay. And you know how to use it. Now there's something called user defined function. Now what it is? User defined function, as the name says, we as a user define it. Okay. Now, for example, let's say you are working in some case study, you are working on some project, and you found that you need to give some output and you need to give some input from your data. Let's say you want to give the name of the person and you want back the age. That is your requirement. Okay. And instead of doing it again and again in a manual process, you want to automate it. So you it came into your mind that why not create something which will automate the entire thing, like something mean. I give the function name and I give the input variables like input digits or the column, and it gives me the output, something like this sort. Okay. And then you want to build something like this. So when you come up with some requirement and you build a function, that is called user defined function. Okay. Guys, am I clear? So there is something called system defined function, which we have seen here, and there is something called user defined function. Are you with me, everybody? Any doubts on the definition? We have not yet started with the code. Anyone? Repeat again. Repeat again. No, no, clear. Okay, great, great, fine, great. I was waiting for this. Yeah. So yeah. So thing is, there's a clear idea. Okay. What functions that R provides? There are numerous functions. Okay, numerous. Okay. Now, if you go to, I probably have posted. I'll in Pinterest. 1 minute. I'll show it to you. Now, if I show you just just as a reference, okay, just have a look all these things, okay. So these are basically all the functions that R has. There are many functions, okay. So I'll just zoom it. Okay, see, a statistical function, data creation function, slicing function, input, output. There are numerous functions that R has. Okay, so there's one thing, and what I wanted to show you is, yeah, see this. Look at this. Okay, all matrices, mathematical functions. So all are this all. If you zoom it, if you download this infographics, and you'll see it's very small here. Yeah, I'll show it to you here. Okay, now if I zoom it, now just have a look. Good, like let's not see statistics, like yeah. So you even understand these terms, right? ANOVA, AOV. Okay, so a proposition test. So these are statistical functions. This is already defined in R, and we just need to use it. So help is one function that is again we missed it, but yeah, it is very important. Okay, instead of writing question mark, you can write help and mean. If you want to see it how it works, write help and you want help in mean and just search for it. Okay, it works the same way how a question mark works. Mean you'll get the same document. See, you got the same document. Okay, so they both work the same way, but question mark is a symbol function, which is very rare. But help is a good function, a proper function we see. Okay, now likewise, you just go to this link and you get many functions. We have seen ls, right? It gives you the file, like all the files. Okay, and then input we saw, what we saw is library we have not seen, read.csv we have seen. Okay, and we have seen slicing and dicing, data frame name, and if I want to remove something then n. So these are some you say system defined functions. We have seen data selections, few examples. If you want to sort something, okay, sort is something we can see now. Let's say sample data is our data set. Okay, I want to sort some column. I want to sort it by salary. Okay, so simple you write that sort, so it will sort it. So see, now the value which you get is in some order. It's not in random order. It's in some following some order, like ascending order. Okay, so all these are system defined function. You are not doing anything. You are just using it. Okay, so I'll request you have a look in these functions. Most of the functions is very clear by its name, and you can even run that in R. Okay, and see it. Okay, and there is something. This way are useful functions. This I can send you over mail. Okay, you can look at it. So here what I did is there's some general functions. We have seen R bind, C bind. We have seen what else? ls we have seen. Okay, reverse will do just it will reverse the order of the string. Okay, you can try this. Sort we have seen. Vector we have seen. Okay, if you want to see system dot, this is good actually to practice. If you want to see system dot time something, it will work something like this. Sys dot time. It will give you the time of the system, like current timing. Okay, 2008. It's 8:48 now here. It gives you the current timing of the system. Okay, current date, sys.date. So it gives you the date. Okay, likewise. So the what I want to tell you is, first is go through the functions, okay, and have a look. This all are self-explanatory. Get working directory, set working directory. These all are functions. System.date, system.time, and the one which we have not seen in statistics we'll see, and machine learning we'll see. In maths, obviously, like it's cosine, sine is there. Okay. Now, given everything, like most of the thing is there, but still, if you need something, so how do we create it? So now we'll see what is user-defined function. So user-defined functions, there are syntax that needs to be followed. I'll send a link, or just follow pin in if you are in Pinterest, just follow, just pull it from there directly. There are many cards, or else like if you want me to send, I'll send 1 or 2 cards you over mail. Okay, or you can follow if you are there in Pinterest. I'll send you the link. There are many cards which will be helpful to you, for you guys, for learning. Yeah, just follow this. You'll get a lot of cards, and like basically they are in R only. So you look this is too good, okay, for you, at least for learning. Okay, like what purpose you want to do, what is your purpose, like you want to load data, so what are the packages available in R? This is beauty for learning. If you want to model some data, you want to do some machine learning, what are the packages? If you want to, let's say, visualize some data, what are the packages? So again, this is very helpful. You can look at this. So follow the link. Fine, and let's move ahead. Now let's get back to our agenda. So now I want to create my own function. Now, so we'll see the syntax first. Syntax. So syntax is very simple. Okay, you give the name of the function. I want to find, let's say, square root, SQUARE root, square root of a number I want to find. So I'll give the name of the function. This is name. This is name. Then you write function here. Function. Okay, and you give, this is it's like parameter, you call it. Okay, you give the name and then write function and then give the parameter. Let's say I give parameter x. So x is nothing but I'll give an input. This will be your input. Okay, then comes the curly braces. Inside this you write your body of a function. Okay, now what I want to do is I simply want to like take that value, and I want to like square root is available. I want to do a square root. So square root is already available, but still SQRT. Uh, math is one. Let me install one package called math, or let's make it simple. So I want to square it. So it will be, let's say, number x 2. Okay, and it will return me a output. So I'll return print y. I want to print y. That means I print the output. Now this is my small function which I created. I simply select all. Okay, and run this. So the moment you run, there will be a functions tab, a separate section created here. Okay, in your environment, and that will specify, yeah, you have created a function square root, and that it accepts one parameter x. Okay, if you want to see the detail, click here. Okay, you get the entire details of the function. Entire details as in like code. Okay, if you are if you are like, if code is visible to you, like you can do anything, right? Then going back, you ran this function, your function is visible in the environment now you want to use it. So how do we use it? Simple. You, as we used to do earlier, just call the function, name the function squ square root, give any value, let's say 4, and run it. Okay, what you got? 16. I basically did square of it, sorry. Yeah, so you got 16. So now you can relate it. Where is the code? Yeah, so now you can relate it with the system defined function. Let's say sqrt is a function. Okay, square root square, or let's say square root. For that we need to import one package, math. Square root in R. Let me check. So there's a, we'll search for a function. sqrt. Yeah, so sqrt is a function. I was correct. Basically, I was not sure. Fine. So sqrt. Okay, just have a look how it works. You give the number and it will calculate the square root for you. So I'm doing that. I'll use 16 and it should give me 4. Correct. Okay, so it is already there, but I've taken a square of it. Now if I give a value, like let's say I given a value here and it gives me output. Similarly, it's a system defined function. Now I created a user defined function. I did the same. I give the input like this and I'm getting the output. Okay, so now there are two things that you need to make sure of it. Okay, the name of the function. Okay, name of the function should not be the one which is existing. If you give that, that will raise an error for you. If I give a mean, this will raise an error because mean is already defined. Okay, so you need to give some unique name according to you. Square root is first thing. Second thing is you need to give a function as a writing. You need to give a parameter and a curly braces. Write anything here in between in the body of function. Now the advantage of functions in R, if you are aware of any other programming language like C, C++, any programming language, okay, so everywhere you have functions, okay, because function is a core part of it, but they all accepts return type. Okay, here for the sake of simplicity, there's nothing you need to define. Just define the logic, whatever you want to do, print it. Let's define a simple logic. X is equal to y is equal to x plus x. Okay, and return y. Then the moment you change the body of a function, okay, you need to rerun the entire function again. You need to compile it, refresh it. Okay, then only the changes will be reflecting. Now if I put 4, I'll get it as output. Okay, but let's say I just added more x. That means I should get 3 times. If I do 4, so 4 plus 4 plus 4, 12 I should get, but still I get 8. The reason is I made the changes in the function, but I have not refreshed it. That means the square root is not updated. The square root function is not updated. You will have to select all, run it again, then call that function again. You get the updated output. Guys, any confusion, anything that you are want me to repeat? Okay, fine. So I'll start with another example. Yeah, great.
So this part remains the same no matter what.
Come again. Yeah, I think I was saying something. Fine. So let's take another example. Okay, so another example will be,
So I was saying that this body part remains the same, right?
yeah, it remains same when it will change according to your logic, what logic you want to implement.
No, like for any function, this body part remains the same, or does it change?
The format remains same. The logic will definitely change. Let's say you come up with a problem tomorrow that you want to you want to see a value and you want to like multiply it by 100. Okay, so it simply you take a value and you multiply it by 100. So this remains same, but like format remains same. Okay, but logic will definitely change, and that is what like needs to be done, taken care of. Okay, now let's take another
Yes, sir.
example.
Thank you.
Like I'll take another example that will enhance the understanding of it. Okay, so think of a situation where you want to create a function. Okay, and based on like the value, it'll make it square root. Now let's actually talk about square root. So I'll delete this. I don't want to delete it. Like you can, if you want to remove, you can remove. Rm variable name. Okay, it will remove the function from the environment. See, it is no more existing here. Okay, it's blank. Now again, I'll create an actual square root function. Okay, square root function. Okay, I'll take a variable y as input. Okay, and I'll try to print the output. So let's take another output in xsqrt is my function name that will compute square root for me, and then I'll input y, square root of y. Okay, then I'll print the value, print the squa square root of y is whatever y you give is x. Okay, and then what you do is you just run it. So just understand the sequence. You create a function, you run the entire function. Okay, then you call the function. This is a calling function. You give the parameter. Let's say I give 16 here, and then I run it. Sorry, I should have given x here, right? The square root of y is x. X is my output, right? So I should have given x. Then again, if since I made changes in the body, I'll have to run it again. String it will not accept. No issues. It will accept if I give a single quote, probably. Let's try a single quote. Okay. 1 minute. Print hello. It is again a system specific thing. Yeah, it will accept double quote only. In your system, it might accept double quote, single quote. So just try it. Fine. So let's remove this. So I'll just create this simple function with print x and try to find the output. So yeah, so it takes x as input and it gives you y. That means square root of 16 as output. Okay. And the moment you create it, so the square root function again appears in your environment section. Yeah. Any doubts so far, guys? Any questions? If not, so we'll start with our functions different. So Ali, this functions that I'm creating, okay, this is a function name that is visible on the environment. This is a global function. Okay, fine. Now, since this is the small logic here, okay, we created, we'll see a small topic. Before I just wanted to take you through all the functions that probably will be helpful and how to use that first of all. So we can do this probably tomorrow, but today, yeah, not this one, the earlier one which I opened. Yeah, so we'll see this some of this. Okay, before that, before coming to this, I'll just take you small topic because we have a complete elaboration of this when we start implementing. Okay, now we saw some data set and we saw some, which is our data set. Okay, we saw data set and we even saw some categorical and some numerical. Now, since you have some decent understanding of econometrics by now, I guess you must have studied the subject of econometrics. In which semester it is? It's in second semester, right, or third semester? Mm, like exploratory data analysis that we do, EDA. Okay, so to start with all those things like all exploratory data analysis, graphing, charting, value imputation, algorithm implementation. Okay, so variable type matters a lot. Okay, why variable types matter a lot? Because you need to understand, like, let's see here, we initially we try to understand the variable, each and every variable, then we proceeded with the our like whatever we wanted. Now let's suppose if you have some missing values. Okay, first of all, any statistical thing, like if I have to find mean, median, standard deviation of a distribution, normal distribution, anything, we need to have a continuous. You need to have a integer value. Like string will not work out. All the strings will never work out. First case. Second thing is factors will never work out when you are talking about R specifically. Okay. So first thing is it should be an integer. Okay, continuous, non-continuous, that is a different thing. It should be an integer. And in case you have a missing value, okay, so let's create a missing value. I create a variable, let's say a small factor x, okay, and it has 1319 something like this, or random number. Okay, I can easily find a mean of it. Oh, you'll get some mean. You get a 5 as mean, a whole number. But the moment I have another variable called, let's say, one something same, but in between you have some called thing na. Okay, then again 8 9. I don't have control on words actually. Wait, yeah, again you have one na. Na is like not available. Simple logic. In R you have na means not available. So you have created a variable that it looks like this. You have 127 na 7, and na means not available. Na is not available. Now it's very interesting to know how R deals with it. Okay, and you'll be like little surprised that R has a different opinion, all together different opinion for NAs. Okay, now how R treats it in normal term, we know NA is not available in layman language. Me and you talking, I'll just tell the values and NA, it's not available. So that is the when data was getting pasted or data was getting created, the like operator by mistake somehow they forgot to impute the data, they forgot to put the data there, so it is NA, fine. But R says it considers it as a infinity. NA R perspective, R's perspective. Okay, infinity. You know infinite, right? Infinite. Okay, what like inverted 8 symbol. Okay, and we know very well any operation with infinity, mathematically I'm talking about, is infinity. Agree? So if I do 2 plus infinity, it will give me infinity. Okay, infinity plus infinity will give me infinity. Guys, am I like, are you with me in this? Then you do
Yes, sir.
infinity minus infinity, again infinity. So basically I mean is like whatever you do, and if infinity pitch in, like if it comes into picture, so the result is no, right? So that is what. So if this is very interesting. If this will, you will come across this infinity minus what was it? I'm forgetting. Infinity, yeah, infinity plus infinity minus 1. So this should probably give you, if you take infinity as a variable, should give you -1 or something. Okay, but here also you get, in R you'll get infinity. So it's a hardcore infinity influential thing. Okay, it is very much influenced with infinity. Now coming to our logic here. So as I said, R consider, it's like different perspective it has, and it consider NA as a infinity. So the moment you have a data set, okay, if you have an actual data set like from a bank, insurance, like FMCG, medical, anywhere, and you get, and any other column, like let's say this is, it's not Y, this is age one. Let's not take it age because 1 year will be very less, but still let's consider this random. This is age, okay, and for some customer age is missing. Now if I want to find the mean age of the customers that I have got, okay, so you get NA. So irrespective of what data you had this data, right? 12779. Irrespective of data what you had, you try to compute mean, okay, you get NA as output because your data set has NA. Whether it is 1, 2, 3, n number. If it is even 1, it will give you NA as output. So this is a big time problem for us. As an analyst, as a data scientist, this is a big time problem because you cannot avoid NA. Avoid is human error, and that will always be there. Okay. So you'll have to use all your brain to treat it, and that is called missing value treatment. Okay, and you'll get to hear a lot, and you get to hear a lot in interview as well. Okay, you sit in an interview, have you worked in our project, did it has a missing value? Yes sir. How do you imputed it? Okay, not explain him the situation, and he'll talk about it like in 10 to 20 minutes. So missing value imputation is one of the important topics that we'll have to see. Okay, now like it has very deep thing, but R as a tool has emerged a lot, this like in handling missing data. So nowadays it has, earlier when I started using it, like it was a little different, but now it has some inbuilt functions that will help you in imputing the missing value. And the best example which I can tell you now is mean. I want to find age, mean of age. I just write na.rm. That means remove the all NAs, and that give me the age. It gives you the age. If it removed all the NAs, it removed 2 NAs. So you are left with 1, 2, 3, 4, 5. Sum it, divide by 5. So you got the output. But This is doable. Generally, people, like, we all will do it. We'll see it, and there are other things as well. I need that RM is equal to true. Okay, and then you can find, like, you can do it. But at times when you deal in practical scenario, okay, just removing the variable will not work out. You are losing on customer data. Okay, let's say, for example, here, let's come to this. This is your customer data. Okay, and you have you want to this history shows that does this customer has historical relation with our company or not. Okay, this shows NA. That means no information is there, and since this is high low, so you cannot like, you can just, first of all, you cannot find mean and all in this. But let's see this catalog if you have any NAs here. You don't have any, it seems here. Okay, so if in case here you have NA, so you can replace it NA.rm and you can find mean and all. Okay, but if in case you have NA and you want remove the, what it does is NA.rm, basically it removes the entire column from the consideration. It will not consider this entire row, sorry. Okay, so for one value which is missing, this 6 is missing, and you remove the entire row, so that means you remove the entire customer from your database, from your consideration, from your analysis. Okay, that should not be the case, because you are losing on important customers. So what people does is, like, what is the general practice I'm telling you, where it is here. Yeah, so general practice is, like, this comes from the business. Okay, I mean, like, the person who is the owner or the senior people in the business, they'll tell you don't remove it, obviously, but replace this NA with the mean of the total. So what will happen, you remove this, you replace this NA with 5.2, and so first you computed mean by removing it, and then once you calculated the mean, just replace all NA with mean. So what happened, you retained the customer, and the entire like, the entire thing is not affected, like, it is it's retaining its standard deviation. Okay, that's what, like, it's retaining its standard deviation. That's the whole idea. Okay, so you have a lot of things, and I have like, basically I'll take you through it. Okay, and just keep in mind like, what is missing, what is the problem. First of all, the problem is the missing value, and then we deal it. Like, there are two approaches which I've showed you. One is direct imputation, like NA.rm, that will work out. Okay, when you are doing analysis, at least when you are learning, that will work out. But I have given you a wider perspective, like real-time experience. In that case, you need to impute it. You need to work with it. You need to solve that problem. Okay. So we have a lot more to be discussed in missing value. Okay. Now, I guess, like, we should stop here for today. Then we'll uh, as concept wise, we'll start tomorrow. Okay, now
Sir, is it necessary that we need to use the mean value in place of NA, or can we use any other value?
no, I'll give you just one example. As I said, there are n number of ways, and that is not you or me who will decide. That will come from the business. Okay, and there will be a situation which I have encountered, okay, in my work experience. Okay, they'll not even ask you to impute mean or something. They'll straight away come to you and tell that if you have any, there are 100 columns, let's say. Okay, we take the percentage. There are many things, like, what's your name?
Sir, Sanjana.
Yeah, so there are many things. Okay, for now, let's say there are 10 columns, let's say, to make it small. Okay, and in one column you find the missing value percentage is more than 10%. Okay, and that is let's say a salary column. Okay, salary column is they have lots of missing values, like 10%. So they'll not take you to tell mean as let's say they don't take mean. Put this value wherever you have missing values, $13,000. Okay, so now you don't have the logic, right? What logic you have? But they know it well, that why they asking us to put 13,000 as a average salary there. Okay, now let's take age. So age, we can put average age very frequently. Okay, sometimes we put median. Okay, median is again a median value compute of the entire available data set of that column, and we compute the median. We put median, we put mean, we put median, we put some constant values. Okay, and at times we put mode as well. Okay, we see which value is frequently occurring. That means like I'm talking about some particular demographic. Let's say I'm talking about Kolkata. Okay, and Kolkata is like if I talk about some particular bank, ICICI, and it has for that particular branch, I see the more the customers of that particular bank, they fall in the range of 25 to 30. Okay, so if I calculate the average or the mean of the entire customer, so it is falling somewhere around 33, 34. But that is not what I expect. So I'll take the maximum frequently occurring value, that is mode, for that particular branch, and I'll put that value. Okay, this is a business actually. Okay, fine. So now I guess it's not mean. Like, don't take it, otherwise it will be very wrong if I just write it here. Okay, what should I write? There are various ways to replace NA in dataset. Okay, and like mean is one way, median is another way. Okay, then we at times mode is very less, but mode or constant values. Okay, I'll send this sheet to you all. Okay, in the mail, whatever things we have discussed and whatever things we have written, you can take it from there. So thanks a lot, guys. Okay, I'll just now tell you, I'll tell you what you need to do now. Okay, now your roles and responsibilities. I'll share the codes with you. DU session, CU session. Yeah. So you'll get some codes. Okay. So today is the third day. So exercises. Okay. There can be some topics which we have not discussed. Okay. Go through it. It is probably it will be into functions. Okay. Or data frame. I've sent you few things. Tomorrow we'll start with visualization, like basics of visualization plotting. So we'll send you the plot to tomorrow. I just skipped one chapter and started with third today. Okay, so I'll send you the codes. Just go through it. Any doubts, we'll discuss first thing tomorrow from that codes. It's exercise. Okay, you have our code here like this. Okay, I'll send you and just go through it. And sorry, I opened the wrong thing. You need to open this. Okay, it's just a code. Everything is written there. You just need to run it and understand, like, if the things that you understand from the code, and after running it, the things which you are getting in the output, are you aligned or not? Okay, take one example. Like here, I'm loading a data set. I'm replicating blue 3990 times, red this many times. So what is my what should be my output? So first calculate it in your mind, run it. Okay, you ran the code. So you're creating a vector first. Okay, in a vector you have how many elements? 1, 2, 3, 4, 5 elements. Okay, first element is getting repeated this many times, and likewise. So you have a big vector. So if you run all, you have something like this. Okay, blue getting repeated this many times, red getting repeated this many times. Okay, so you need to understand this. Okay, just keep on running. It's a small code, but it is very helpful. Okay, so I've created this basically for learning perspective. Okay, so yeah, that is it, guy. Okay, let's meet up tomorrow with again with the same agenda of learning R. And in case you have any questions, put it down in a pen and a paper. Okay, that will be very helpful. The reason is, like, tomorrow when we sit, it might miss out, like what you thought of asking and all.